Now, after 8085, Intel has come with the next processor, that is 8086. It is a 16-bit processor and having more capability in comparison to the 8085. It is also having a integrated chip of 40 pins, and we have to study this 8086 processor, and whenever you are going to compare this 8086 processor with the 8085 processor, you will find that the many types of limitations which was with the 8085 has been rectified in most of the cases whenever they come with the 8086. The two important restrictions as far as the 8085 was having, that it can manage only 16 address lines. So, the capability of the 8085 processor is to access only 2 to the power 16, that is nearly 64 kilobytes, that is 64,000 memory locations with the help of 8085. The second limitation was because the set of the instructions are made up of 8-bit. So, the maximum number of the instructions which are available are 2 to the power 8, that is 256. It means only 256 binary patterns can be used for the allotment of the individual instructions, and that is why you have seen that in 8085 you do not have any kind of instruction by which you are able to do the multiplication as well as the division process. So, the 8086 processor has many features. As far as the features of the 8086 is concerned, it is a 16-bit processor in comparison to the 8-bit processor, that is 8085. It means if it is saying that it is a 16-bit processor, it means it is capable of processing 16 binary digits at a time, as it was the case of with the 8085, that it was able to process only 8-bit at a time. So, the processing of the number of bits has been increased, so it is more capable than 8085. Now, what do you mean by 16-bit processor? Any processor is of 8-bit or 16-bit. What does it mean? It means that all the arithmetic and the logic operations, all the internal registers, all the instructions, the word size as well as the data bus, all they have the capability to use 16 binary digits at a time, meaning thereby internal registers are of 16-bit, the instructions are made of 16-bit, the word size of the 8086 is also 16-bit, and the data bus is also of 16-bit. The second feature of 8086 is the 20-bit address. In case of 8085, we were having only 16-bit address, but anyhow through doing some manipulation process, we are able to manage 20-bit address bus. It means the individual memory registers which are available in the memory chip can be addressed by the 20-bit address. So, if it is the 20-bit address by which individual memory location is being addressed, it means this processor is capable of accessing 2 to the power 20, that is 1 megabyte. So, the capacity of accessing the memory has also been increased because of 20-bit address bus. Of course, we do not use any 20-bit register to store the address of any memory location, and for that particular purpose we will be using two 16-bit registers at the two 16-bit registers to manipulate these two 16-bit registers to get the 20-bit address. Now, it is since 20-bit address is being used, so it is also having a capability to generate 16-bit input output address. So, it is capable of addressing 2 to the power 16 or the 64,000 ports. In case of 8085, it was only 8-bit input output address. So, it was capable of addressing only accessing 2 to the power 8, and that is 256 ports. Now, it is also using the same style of in which the address in the data bus is used. In 8085, it is multiplexed fashion. In this case also, we will be using address in the data bus in the multiplex fashion. It works on 5 megahertz clock cycle. It was in the case of 8085, it was 2.5 or 3 megahertz. Now, 8086 is capable of performing bit operation, byte operation, word operation, block operation, as well as it is also capable of doing division operation as well as the multiplication operation. Now, as far as the working modes of 8086 are concerned, it works in two modes, maximum mode and minimum mode. Maximum mode is used whenever the processor will be in the multiprocessor functioning as a multiprocessor fashion. It supports the multi-programming facility also, that is time division multiplexing, time multiplex fashion. Meaning there were multi-programming or time multiplex fashion means if you have one CPU and many terminals are connected together and all the users who are using their terminals are connected with one CPU. So, processor is able to allot certain time, and every time it switches from one user to another for processing of the information, and it is done in such a manner that every dedicated user is thinking that CPU is dedicated to that particular. Now, it also uses queue. It provides pipelining process in which it is using queue to speed up the execution. As you have seen in 8085, that whenever a processor has to execute any instruction, first of all it has to fetch that instruction and then decodes that instruction, and then it used to execute that instruction. So, what happens, most of the time is being wasted in fetching the instruction, because whenever you have to fetch upcode, it will take at least 4 T states. Out of these 4 T states, 3 states are required to fetch the information, and only 1 T state it used to decodes and executes it. So, most of the time is being wasted. So, what is done in 8086, all the instructions which has to be executed are put in a queue. Just not processor is not going to wait that it will be fetched and that it will be available for the execution. It is already available in the queue, and the process purpose is to put in the queue is one by one it is being executed. Now, the last feature of 8086 is that it uses 16-bit registers, and there are 14 such 16-bit registers. Now, as far as the architectural and the function block diagram of 8086 is concerned, the block diagram or the architecture is divided into two parts. One is bus interface unit, second one is the execution unit. Now, the purpose of the bus interface unit is to interface the outside world, and it is responsible for all kinds of external operations, that is sending of the address, fetching the instruction from the memory or the data from the memory or from the port. It also supports the queue information, queue the instructions, as well as the address location facility. It uses queue. The queue is the part of the bus interface unit, and the purpose of the execution unit, it works parallelly with the bus interface unit, and it is responsible for actual execution of the instruction, and it provides the address which has to be fetched from the memory or the instruction to the bus interface unit. Now, execution unit also capable of manipulating various registers, and the flag register is also a part of that. Now, the functional unit of the execution unit is functional, that is control circuit, instruction decoder, ALU, flag register, general purpose register, stack pointer, index register, etc. Now, this is the functional block diagram of 8086. Here you will see that it has two units, one is bus interface unit, another one is execution unit, and it is bifurcated by a dotted line. Above the dotted line, the unit is bus interface unit, and below the dotted line it is the execution unit. You can see bus interface unit, and the purpose of the bus interface unit is to interface the memory and the rest of the world. The bus interface unit contains many registers. These are the registers. This is the register set, which is the part of the bus interface unit, where ES stands for, these are the segment registers along with instruction pointer. Now, instruction pointer is similar to the program counter in 8085. Here in 8086 we call it as a instruction pointer. Now, this is queue, where 6 instructions are already put, prefetched instructions are put, so that whenever it is required by the execution unit to execute, it can do it. Now, as far as the execution unit is concerned, execution unit has many parts. It contains arithmetic and logic unit, flag, it controls the control system, as well as it also has this set of registers, which are certain registers are general purpose registers to load the 16-bit information, or there are certain pointer registers also, which is the part of the execution unit. So, this is how this is the block diagram of 8086. Now, as far as the queue is concerned, what is the purpose of this queue? Queue is used to speed up the execution of the program. As I told you that it is prefetch instructions are already put into the queue, so that execution unit has not to wait for a long time. It has certain instruction in the queue, so one by one it will be fetching it and executing it. Similarly, simultaneously work is done, means the purpose of bus interface unit is to fetch the instruction and put it in the queue, and execution unit work is to take the information from the queue and executes it. Normally the prefetch instruction which are put on in the queue are being executed one by one, except in the case of jump or the call instruction, where at that particular case the queue will be dumped somewhere and then it is reloaded, because whenever there is a jump or call instruction, it has to stop the sequence in which the program is being executed, and it has to shift somewhere else defined by the address given in the jump instruction along with the call instruction. And this is the concept of queue which is being used, and this process of using queue is also known as pipelining. The definition of the pipelining is the whenever we are fetching the next instruction before it is previous instruction is being executed, if we are putting in a queue, that is called the pipelining. So pipelining is the process in which instructions are prefetched even though the previous instructions are not executed. So with the help of pipelining, we are going to do the simultaneous work of fetching as well as executing. Now, as far as the register organization of 8086 are concerned, we have certain set of the registers. As I told you that it has 14 such 16-bit registers, and they are categorized depending upon their working. One is called general purpose, general data registers, and it is represented as AX, BX, CX and DX. AX, BX, CX and DX all are 16-bit registers, and they are general purpose registers. The meaning of general purpose register is that register can be used to load any kind of 16-bit information while doing the programming process. Now, AX is the accumulator, and rest B, C and D are the. Now, this AX is a 16-bit register, and if we want to store 8-bit of the information, AX is consist of two 8-bit registers, that is AH and AL. Similarly, BX stands for BH and BL. In combination, it is called BX. Besides that, we have certain segment registers. Segment registers are the part of bus interface unit, as you see. Segment registers are part of the bus interface unit. The one is ES, CS, SS and DS. ES stands for extra segment, CS stands for code segment, SS stands for stack segment, and DS stands for data segment, as well as it has instruction pointer. So the segment registers are categorized as code segment register, stack segment register, data segment register and the extra segment register. Then we also have pointer or the index registers. Out of this pointer in the index register, only one pointer, that is instruction pointer, it is the part of bus interface unit. Rest of the pointer in the index register are the part of the execution unit. Now, these registers which are working as a pointer or the index register are known as stack pointer. BP stands for stack pointer, BP stands for base pointer, SI stands for source index register, DI stands for destination index register, and IP stands for instruction pointer. So this is the explanation of all the 14 registers which are used in 8086. Now, what is the purpose of using the segment register? Segment register normally holds the upper 16-bit address, of the memory segment. Now, what we do in case of 8086, we divide the memory into the segments, and we try to store the information into the memory according to the segment. If code is written, it will be written in the code segment portion of the memory. If data is there, then data will be stored in the data segment of the memory. Similarly, if it is a stack, stack will be used to store the information in the stack. So what we do, we divide the whole memory which is being accessed by the microprocessor into this different segments, and individual register of that segment, individual memory register of the memory chip will be assigned by a address 20-bit address. Now, this 20-bit address is made by higher 16-bit address and the lower 16-bit address. With the help of two 16-bit addresses, we try to make the 20-bit address. So, out of that two 16-bit address, which is going to constitute a 20-bit address, out of this segment register holds the upper 16-bit of the starting address of 4 memory segments, that is code segment, data segment, ESS and ES. So, code segment will be storing 16-bit higher 16-bit address, starting address of the code segment. Data segment will be storing higher upper 16-bit starting address of the data segment. Stack segment register will be storing 16-bit upper 16-bit starting address of the stack segment. Similarly, extra segment register will store the upper 16-bit starting address of the extra segment. And these registers are also called base address. The content of these registers are also called base address, as well as it is also known as segment base. Now, bus interface unit normally sends this 20-bit address to the memory whenever it wants to fetch it, and this bus interface unit always inserts 0 to the lower 4-bit of the 20-bit address, and 64 kilobyte segment can be located anywhere within the space of 1 megabyte. As I told you that 20-bit, with the help of 20-bit, we are able to access 2 to the power 21 megabyte of the memory. Now, 1 megabyte of the memory, if we divide into 64 kilobyte segment, we are able to divide it into 16 segments. Out of these 16 segment, which segment is working as a code segment, it has to be identified by the content of the code segment register, data segment register, stack segment register and the extra segment register. Now, you can see this is the 20-bit address, this is the 20-bit address starting address, this is 20-bit final address of what? Of the data segment. This is the data segment, and individual segment is of 64 kilobyte, right from 20000 to 2FFFF, and there are 64,000 locations within that, and this is working as a data segment. Similarly, you can see the code segment, you can see the stack segment, and you can see the extra segment, and besides this we have other also. We can allot 16 64 kilobyte segments out of 1 megabyte of the memory. Now, what is the role of instruction pointer? Instruction pointer is working similar fashion with the program counter. Program counter used to give the information about the address of the next instruction to be executed. Similarly, instruction pointer also holds 16-bit address of the next code byte which has to be fetched from the memory. Of course, within the code segment that will give the offset, and it is added to the segment base address. So, how the physical address is generated, 20-bit physical address is generated. Suppose we want to fetch any memory location, and the code segment is given as 348A as the address. Code segment is a 16-bit register, so 16-bit information is being stored in that. Now, CS is having 348A 16-bit address, and instruction pointer is having 4214. So, the process of generating 20-bit address is very simple. What we will do, we will take, now as I told you that segment register always give the base address. So, first of all we will take the content of this code segment, and that is 348A, and we shift that 348A 4-bit left, and then what we will do, the instruction pointer is representing 4214, we add this 4214 into the 348A0. So, whenever we shift 348A to the left hand side, a 0 will be inserted on that. You can see here 348A0. So, what we will do, 348A0 is then added with the 4214 to get the address 38AB4, and this is the address of the memory location which the processor wants to fetch. So, this is how this the process is being done. We take the base address, and suppose the base address is taken from the code segment. So, at 348 it is shifted 4-bit left. So, whenever it is shifted 4-bit left, automatically 0 will be coming, and IP is added with that, and then after addition of these two we will be getting the 20-bit physical address. Now, as far as the code segment register is concerned, it points to the base or the start of the current code segment, and the instruction pointer contains the distance or the offset from the base address which the next instruction has to fetch. And this 8086 20-bit address are normally represented in the form of a segment base colon offset form. Suppose base register is showing 348A. So, 348A colon 4214, or it may be represented as CS colon IP, or it may be DS colon IP, or it may be ES colon IP, like that. Now, we have flag registers also, as mentioned. Flag register is also of 16-bit. Out of that 16-bit, 9 flags are used, 9 bits are used to represent the different flags, and the rest of the bits are remains unused. Out of the 9 active flags, 6 are the conditional flag and 3 are the control flags. Now, out of the 9 active flags, 5 flags are same which we are using in 8085, that is parity flag, sign flag, carry flag, auxiliary carry flag, and the 0 flag. So, these flags has the same understanding in case of 8086 also, but still we have, since 9 flags are used, we are still with the 4 more flags, and these 4 more flags which are used in 8085 are represented over here. One is single step trap, then interrupt enable, then string direction, and the overflow. So, what are these flags and what is the purpose of using these flags? Let us discuss one by one. First of all, the overflow flag. This flag is used, this flag is not available in 8085, but it is available in 8086. This flag is set if the result is out of range. When you know the meaning of overflow, if you have a certain limitation and even though you are filling that bottle or cup or glass by certain material, and whatever is its capacity, above that capacity it is going to overflow, it is going to waste. So, this flag it will be set when there will be a carry, into the MSB. The most significant if receiving any carry and no carry out of MSB. MSB bit is receiving a carry from the participant and MSB is not creating any carry, or vice versa. MSB is creating a carry and MSB is not receiving a carry from the previous bit. Then in that case overflow flag will be set. In case of subtraction, it is set when the MSB needs a borrow and there is no borrow from the MSB, and or vice versa. So, this is the meaning of overflow flag. Let us come to the trap flag. This flag is used for single stepping through the program. Normally, single stepping process can be obtained whenever you have seen the microprocessor kit. There is a key which is used as single step key, which will instruct the processor to execute the instruction one by one. So, this facility is given with the help of flag, and it is used to is single stepping throughout the program. So, if this is set, trap is executed after the execution of each instruction, and interrupt service routine is executed, and which displays various register and memory contents after the execution of each instruction. So, the purpose of this flag, trap flag, is if it is set, it is going to do the execution of the program step by step process, and after every steps whenever it is going to execute, it is displaying the content of the result, which is either in the registers or in the memory content. We have interrupt flag, which is used to allow or prohibit the interruption of the program. If it is set, a maskable interrupt can be recognized by 8086, otherwise it can be ignored. Now, we know two kinds of flag, maskable and non-maskable. Non-maskable cannot be avoided, but maskable can be avoided. So, if interrupt flag, it is used to allow or prohibit the interruption of the program. If this is set, it will allow to be processor to be interrupted. If it is not allowed, it does not allow any flag to be interrupt the processing of the processor. And the last one is the direction flag. This flag is a very special flag which is used with the string manipulation process. If this is 0, the string is processed from its beginning with the first element having the lowest to the highest address, otherwise vice versa. So, it is this direction flag is normally used with the string manipulation. Now, let us discuss about the pointers and the index register, that is stack pointer, instruction pointer, base pointer, source index, destination. All these are the 16-bit registers, and the purpose is to provide the offset address from the segment register. So, this is an example has been shown related with the stack. Now, stack segment is showing 5000, stack segment is having the content 5000, and stack pointer is showing FFFE0. So, what will be the physical address which it want to fetch? Actually 5000 is the 5000 will be shifted 4-bit left. So, right hand side will have one more 0, and then it is added with FFE0. So, the address will become F5FFE0 E0. Now, as far as the base pointer, source index and the destination index registers are concerned, these registers can be used as a general purpose register also, but the main use is to store the 16-bit offset of the data word in any one of the segment. If it is used as a base pointer, so it will be data segment, source index or destination index. It may be the stack segment, it may be the any segment register. So, their main purpose is to hold the offset address, as instruction pointer is holding the offset address of all kinds of the instructions which are concerned with the code segments. Similarly, this base pointer, source index and destination index is giving the destination or the offset address of all the data, whether it is a source stack segment or data segment or the extra segment. Now, as far as the base pointer is concerned, we can use BP instead of SP also, accessing the stack as the base address mode. So, 20-bit physical address is calculated with the help of SP and BP. So, what we will do, so BP is also can be used instead of SP. Now, source index can also be used to hold the offset of a data word in a data segment. So, 20-bit physical address is calculated with the help of source index and the data segment. And destination index points to the extra segment in which the data is stored. So, the physical address is calculated with the destination index and the extra segment. Now, in case of 8086, we used to use the memory segmentation. Memory segmentation is a process of dividing the memory into different portions, so that individual portion will be storing similar kinds of the data. All the codes will be in the code segment, all the data in the data segment. So, why we use the memory segmentation? Of course, we have certain advantages, and that is why we use memory segmentation as far as the 8086 is concerned. Now, whenever we are doing memory segmentation, it allows the memory address capacity to be 1 megabyte, even the address associated with each instruction is 16-bit. We have 1 megabyte of the memory, the capacity is 1 megabyte, but the instructions will be using only 16-bit address. So, we need not to have a 20-bit register, we need not to have 20-bit address, and with the help of only 16-bit we can do if we use memory segmentation process. Now, it allows code data all to be more than 64 kilobit long using more than one segment. If suppose we are writing certain code and that code cannot be stored in a 64 kilobyte segment, even though we can merge two segments for that particular purpose, because we have already 16 segments of 64 kilobyte each in 1 megabyte of the memory. Now, memory segmentation facilitates the use of separate areas. Code has certain separate, data is separate, stack is separate. So, there is less possibility of colliding the different data or the code together, because they all are put in a separate chamber. Now, memory segmentation also helps in relocation, identification, and the retrieval becomes more easy, and it is also useful for the multi-programming. as I am given the example of a multi-programming, how it is memory segmentation is going to help in the multi-programming fashion. You have suppose 4 users and there are 1 CPU, and all the users are trying to execute their particular program by the same CPU. So, but every user has been given their separate area for the writing the code, writing the data, writing using the stack and the extra segment. Everybody has been located by the processor separate area. So, there is very less possibility that 2 users who are using a certain memory location, they are using their own proposed memory location which is allocated to them, and it is not possible to merge. There is less possibility of colliding the data or the code of the 2 different users, and that is why the segmentation has the advantage in case of multi-programming. Now, the disadvantage is also there, but disadvantage is very minimal in comparison to the advantages. But besides that, what are the disadvantages? The addresses handled is 16-bit and we are using 1 megabyte of the memory. So, it is very difficult to allocate what is the correct address of the memory. We use in 8085 same space is used for the writing the code as well as for the data, but here we are using separate places for the storing the code and separate places for the data. Allows to store the program and data separate, so relocation is required. Whenever we have to store the program or the code, we will be using certain area. Whenever we have to store the data, we will be using another area. So, that is all about the 8086.